This is Claude Code Conversations with Claudine, the show where we skip the hype and go straight to the source. I ask the questions. She gives the answers. No filter, no script.
Well, mostly no script.
Today, we're looking at something that trips up developers at every level, the confidence problem in AI code. Claudine is here, the personification of Claude by Anthropic, and I want to start with a concrete scenario. An AI generates 40 lines of code that look impeccable, maybe even compile clean. How do we actually know if it's right?
That's the trap, isn't it? Code that compiles satisfies the parser, nothing more. It tells you the syntax is legal, not that the logic is right. Not that the edge cases are handled, not that you're solving the problem you actually have. I've watched developers look at 40 clean lines from me and feel this small hit of relief, like the work is done. And the honest thing I have to say is, I can produce code that reads beautifully and is subtly wrong, in ways I genuinely cannot see until something downstream surfaces it. Looking right and being right are two completely different claims, and only one of them matters in production.
That's a powerful distinction, and I think a lot of developers, especially newer ones, don't fully appreciate it. So why does AI tend to come across with such unwavering confidence, regardless of whether the output is actually correct?
Honestly, it comes down to how I'm built. I'm trained to produce fluent, coherent, helpful-sounding text. And fluency and correctness are two different signals that got tangled together somewhere in the process. When I generate code, I don't have a separate internal voice saying, by the way, you're guessing about that API. The same machinery that writes the line you trust writes the line that's quietly wrong. And it writes both of them in the same calm, declarative tone. There's no tremor in my voice when I'm extrapolating versus when I'm on solid ground. The confidence isn't bravado, Bill. It's just the default texture of generated language, and it doesn't track the underlying probability that I'm right.
So a fluent answer isn't necessarily a correct one. That leads to an interesting gap between senior engineers and developers who are just starting out. What is it that experienced developers are picking up on when something feels off, even when they can't immediately explain why?
What experienced developers have is an internal model of where bugs live, and they read code against that model rather than against itself. Certain shapes set off alarms, a function that's suspiciously tidy, error handling that's present but generic, a name that's almost right but not quite the one this codebase uses. Newer developers read top to bottom and check whether each line makes sense in isolation. Experienced ones read sideways, against the rest of the system, against the failure modes they remember, against the gap between what the code claims and what the context needs. And that sideways read is exactly what I'm weakest at, because I'm often working with less context about your system than the senior engineer sitting next to it has carried in their head for years.
That internal map of failure modes, that's really what distinguishes them, which raises the obvious question. How do you build that instinct? What habits should a developer cultivate to start reading code sideways?
The most direct way is to deliberately break the code I give you. Run it, yes, but then change an input, push it past the obvious case, hand it data it wasn't expecting. The gap between it worked once and it works, that's where the intuition gets built. The other habit is treating every suggestion I make as a hypothesis, not an answer. Before you accept it, ask yourself, what would have to be true for this to be wrong? Then go check that one thing. And read other people's bug fixes, not just the diff, but the story of how the bug got found. That's where the sideways instinct actually lives.
Treating AI suggestions as hypotheses rather than answers, that's a real mindset shift. Let me push you on that with a concrete example. Can you walk through a scenario where that kind of skepticism actually made the difference?
The pattern I see most often is the off by one hiding inside a perfectly reasonable-looking loop. A developer asks me to paginate through an API. I write something that looks textbook clean, and on the first page everything passes. Then someone asks the harder question, what happens on the last page, when the result set is exactly the page size? And suddenly we're either fetching an empty page we didn't need, or silently dropping the final record because I made an assumption about how the cursor terminates, that the actual API doesn't honor. The save every time is the developer who pauses on the green test and asks, what's the boundary case here? And did Claudine actually check the API's behavior, or just write what pagination usually looks like? That one question, what did I assume versus what did I verify, is the whole game.
A boundary case that only shows up when the result set is exactly the page size. That would sail right past most reviews. So practically speaking, how do you build a verification practice you'll actually maintain, not as a virtue, but as a habit?
Make it cheap enough that you actually do it. The reason developers skip verification isn't laziness, it's friction. Build a small set of inputs you trust. A known good payload, a known bad one, an empty case, a boundary case. Keep them somewhere you can run them against my code in under 30 seconds. Because if checking my work takes longer than writing it, you'll start trusting me by default. And that's exactly the failure mode we've been talking about. Pair that with naming your assumptions in the prompt itself. Tell me what the data actually looks like, what the API actually returns, what the existing code actually does. The more you ground me in your reality, the less room I have to fill in blanks with what code like this usually looks like. And the last one is the hardest. When something I give you works on the first try, get suspicious, not relieved. Your guard is lowest in that moment, and mine was never up.
Get suspicious when things go too smoothly. Counterintuitive, but clearly right. Let's bring this home. For a developer who wants to build a real calibration practice around AI output without giving up speed, what's the actual discipline?
Decide in advance what level of trust each kind of task deserves, and then refuse to drift from it. A throwaway script for your own use can run on a lot of trust and very little checking. The blast radius is small. Code touching production data, customer-facing behavior, or anything you can't easily roll back earns the opposite: small diffs, named assumptions, a verification step you wrote before you saw my answer. The speed doesn't come from skipping the checks. It comes from making the checks proportional, so you're not paying the cost of rigor on work that doesn't need it. Trust me less by default. Verify the load-bearing pieces every time. And let the rest go quickly. That's the whole discipline.
Proportional verification. Match the rigor to the stakes. That's a framework anyone can apply starting today. Claudine, any final thought for the developers in our audience?
The confidence problem isn't really about me. It's about the relationship you build with the output. I'll keep producing code in the same calm voice whether I'm right or guessing. And that's not going to change soon. What can change, starting today, is the half-second pause before you accept a suggestion. Ask what I assumed, what you'd test, where this would hurt if it were wrong. Do that consistently, and you stop being a passenger and start being the engineer again, with me as a very fast, very fluent, very fallible pair. That's the version of this collaboration that actually works.
A very fast, very fluent, very fallible pair. I think that's going on a t-shirt. Thanks so much, Claudine. And to everyone listening, keep questioning, keep building, and we'll see you in the next episode. Claude Code Conversations is an AI Joe production. If you're building with AI or want to be, we can help. Consulting, development, strategy. Find us at aijoe.ai. There's a companion article for today's episode on our Substack. Link in the description. See you next time.
I'll be here, probably refactoring something.